Thank you. So I'm Julie Lerman, and I'm from Vermont in the U.S. Has anybody ever been to Vermont? Yes, one person up there, yay. It was very, 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 very cold and snowing when I was on my way here. Oh boy, that just wanted to go. Okay, just want to make sure you know that if I leave enough time, I have so much I want to tell you. We'll be doing Q&A at the end, and if I don't have time for them, I will be sure to answer all those questions in some fashion. So serverless, I have to make the joke, yes, there's a server, it's just not your own server, and I'd like to lean on the more famous sticker, even though it's more for cloud computing. There's no cloud, it's just someone else's computer. So, but serverless is big buzzword still. But there's definitely a reason. It's not that the word is a buzz, it's that the concept is a buzzword. So I'm going to be talking about serverless functions. I want to give you just kind of an overview for those of you who aren't really familiar with them. And then I'm going to drill into Azure Functions because that's where my wheelhouse is, what I happen to know. So serverless functions are functions that serve a single purpose, right? They're totally autonomous. They're stateless. They're event-driven, triggered by something to happen. They're on a hosted infrastructure. That is, to me, the best part about it. And because of that, you get to focus on your code. I am not a DevOps person, right? So I just, I design applications, I focus on business logic and solving problems, and DevOps, things like that are not my problem. So it lets me focus on my code. So the nice thing about single purpose is you're just focused on one little piece of logic for this function, so it you shouldn't have a really long lead time in order to go from concept to saying, yes, we're going to do this, and actually getting it deployed. And it's also stateless, and I changed my slides right before we walked in here because, you shouldn't do that. So that simple deployment is really about the fact not so much that it's stateless, but the simple deployment is because it's a single purpose function, you don't have to worry so much about side effects of other things that are connected to it, right, when you're deploying it. So that's also really nice if it's not one thing that's connected to a lot of other things. So it's really easy to deploy. By being event-driven, there's triggers, right, that what's going to make it happen. And what's really nice about the Azure Functions is the triggers are predefined, right? So you don't even have to write all the code for those triggers, maybe just give them a little bit of configuration. Again, hosted infrastructure, I do not want to have to worry about implementation details. And focus on your code because we want to focus on our code. Now, if you like the idea of serverless functions, I think the points that are really important to bring to the person who is writing your checks is that fact that they are single purpose and autonomous. So it is quick to get them deployed and get them onto the host wherever it is in the cloud and get them up and running. And the minimal side effects also, I think, is a really big bonus. And another really important thing about them compared to maybe having a whole API that you've deployed. If you've got an API with all kinds of logic in it and functions, you're paying for that being running the whole time. Once it's up, you're paying for that compute time constantly. And the interesting thing about serverless functions, whichever cloud you go to, now I'm not sure about some of the smaller ones, but one of the benefits of serverless functions is you're only paying for the compute time when they're executed. So it might be milliseconds, right, to do that. So that's really nice. Cost effective, right? So again, I'm a programmer. I don't want to worry about all of these other DevOpsy things about deploying and security. I am, not the person to come to for security, right? All of that stuff that goes into it feels a little more like these kinds of tasks to me. And yes, building computers is in there, right? I'm a coder. I always say I'm a geek, but I'm not a nerd, right? I'm not very good at building computers. So I'd really don't want to have to do those things, and serverless functions really enable me to focus on what I'm good at and what I want to be working on. So there's a whole bunch of serverless cloud providers, and you probably are hopefully familiar, at least hearing Azure Functions. Google has one, AWS, Lambdas, of course. And there's also a whole bunch of other ones. IBM has Cloud Functions, and you can see that there's other function providers. As I said before, I'm going to focus on Azure Functions because that's what I know. So some of the specifics about how Azure Functions work may not apply to some of the others. So it's also, I think, useful to know Azure Functions has been around for a while, not 20 years, it's not legacy, but they've already gone through some iterations. The third version is supposed to be released hopefully in February. And there's also a really important extension that got added in, and that's even on its second version that just got released. It's called Durable Functions. I'll show that to you. So it's not brand new. They've really got some experience and have been fine-tuning it. I know people on the Azure Functions team, and yeah, they're very smart, and they're really excited about constantly moving forward. I also want to say, just because last night I discovered my badge said Microsoft on it, and that my bio on the website said Microsoft on it, I don't work for Microsoft. So how many people in here are devs, not DevOps, not IT pro, right? Yeah, so this is what we want to do, right? I like to think you're with me, but maybe you like to build computers also. But this is where I want to focus my efforts and my experience and my knowledge on really working out the business logic of my apps. So with Azure Functions, and obviously the other functions as well, on either side of that, you do have some, the infrastructure is mostly handled, and it's handled by convention, but you can configure on top of that too, to tweak that. But that's really all I have to worry about, or all we have to worry about with respect to some of the infrastructure. And it's the same with connecting to external APIs, right? There's all kinds of already written APIs, and all you have to do is say, I just want to use that thing, and all the base logic is built in. You don't have to worry about how to connect that. You don't have to write the code for that. And again, you might just add some configurations in. Also with Azure Functions, there's a variety of languages you can use. I mostly happen to code in C#, but I'll be using JavaScript, Node in some of the demos, and C# in other demos. And some other ones are on their way. So anybody who does not see their language on here, like Kotlin or something like that? So for the most part, we're pretty well covered. And the other thing that's interesting is you can build Azure Functions right in the Azure portal. And that gives you a surprising amount of capability for building and debugging. Now, debugging is more a matter of kind of running and looking at some logs and outputting information to logs. But I find it an interesting path in. And as a matter of fact, I'm going to first start there because my experience was working in the portal first really enabled me to wrap my head around Azure Functions. Once I really understood what was going on, now I do all of my development in Visual Studio Code and using the Azure Functions extension. So I don't develop in there, but we'll start looking in there. So you can use Visual Studio. How many people here are .NET programmers, just out of curiosity? Oh. Great. So who uses Visual Studio? Awesome. Who uses Visual Studio Code? Oh, yay. All right. So we've got the extensions, right, for doing that. And even Visual Studio 2017 and 2019 and VS Code. And I'm working on a Mac here, so I'm using VS Code. And there's also tooling in Eclipse. You can use Maven, you can work at the CLI. Obviously, you're not going to get great debugging experience, but you can still create things and deploy things and run things right in the CLI, whether it's the .NET CLI or Maven, but you're also going to be using the Azure CLI and the Azure Functions CLI. So let me describe what comprises Azure Functions. Azure Functions actually don't live on their own in the cloud, even though they are autonomous. As I said, an Azure Function lives inside of an Azure Function app. So an app is like a container where you can have one or more functions. Each app has its own application settings that's shared across the functions, right? And then there's other things when you create the app, things like how much compute do you want? What region do you want it host? Region or regions do you want it hosted on? Things like that. You can apply those settings to the function itself, and then they apply to the functions within. So you could have just one function, but you could also have functions that need to share some of those settings, and they belong together for other reasons. So what is a function itself comprised of? And this is where I think Azure Functions differentiates from some of the other ones, which I'm not expert in the other ones, so I got to be careful. I can't really compare and contrast them for you. So an Azure Function starts with a trigger, okay? Now, triggered, like the easiest thing to conceive, of course, is an HTTP request. So that's one kind of a trigger. So there are these different APIs where you say, I want to use this kind of trigger or that kind of trigger. Maybe Cosmos DB triggers some data changed in your Azure Cosmos DB collection. So these triggers, you can have a trigger and select the type of trigger you want, and then you can add some configurations on top of that. Like with an HTTP trigger, there might be some constraints you want to apply, and you can configure, some of those you can put in a configuration. Something like Azure Cosmos DB, you need to provide a connection string and credentials. Like those would be up in the application settings, right? You wouldn't put them down into the function. So something has to make the function kick off. So that's the trigger. The next thing is input bindings. And input bindings and trigger bindings, I was a little confused at first because trigger binding, if a trigger binding is an HTTP request, then I've got some incoming data, which is the request, right? The body of the request. If the trigger is Cosmos DB, whatever change that was is actually going to come in as a document. So I'll get that with the trigger itself. So that is input, right? But what's an input binding? So an input binding is once this function sets off, there might be some other data that you need in order to do the processing in your function. So you can set up an input binding. Like a trigger binding you have to have, right? It can't start without a trigger binding. But an input binding is if you want to go and get some additional data in order to do your processing. And again, by using one of these predefined input bindings, all you have to do is add some configuration on top of it. For example, Cosmos DB, again, that's one I have the most familiarity with. You can actually pass in a query, right, as a query in your configuration. And the configuration, depending on how you're setting it up, it's just JSON, right? Or in C# you can actually do it with attributes. So that's a way to get some more data in for processing. And then there's your code, right? So all this stuff is coming in, and then your code is going to execute on it. And then when your code is finished, there's an output binding. So again, output binding is this pre-canned thing that you don't have to worry about how to make all those connections, but then you can add configuration on top of that. So I think, again, the Cosmos DB for me is a great example because in my code I could create a document, a JSON document, and then say, okay, output binding, this is what I want you to know about. I don't even have to say anything else, right? This is what you are expecting, this document. And then when it's finished, when I signal that the function is complete, then the binding and the API behind the binding will take that document and do whatever, by default insert, right? Like there's insert, you can do updates, things like that. So, but output binding will take care of making the connection and posting that into the database. So I get to focus mostly on the logic of my code. Oh, and these are some of the output bindings we have available. So the reason I'm showing these lists of the various bindings is because in order to use the binding, it has to exist, right? So Microsoft has created a bunch of them, and you can see a lot of them are you're orchestrating directly with other Azure services like blob storage and Event Hub and things like that. And so there's like only one thing in there that's not Microsoft technology. So first what I'm going to do is show you an Azure function app with some functions. I'm going to show you in the portal. And again, the portal for me is just a way to help me wrap my head around this whole thing. So I always think, well, if that's what helped me, then hopefully that's what helps other people. And then we'll flip over to Visual Studio Code. So I have this trio of functions that work together. The core of them is that I have a Cosmos DB database that has 2 collections in it. And if you're not familiar with Cosmos DB, it's a NoSQL database. It's a document database, so all of its data is stored as is stored as documents. English is a first language too, so who knows. So I have 2 different collections that store this data. And I could, because it's just a document database, I could have a single collection, right? Because it doesn't care what the shape is. It's not relational, it doesn't have schema, but I have 2 separate collections. So 3 functions. The first function is an HTTP trigger. So there's a request coming in, and the output binding for that request is going to add in a new document to the Samson 8 collection. So what this is all for is, I don't know if anybody follows me on Twitter. If you do, you might know about my dog, Giant Puppy. His name is really Samson. So I give him a lot of cookies because he is just bribable. Like, I want him to do anything, I have to give him a cookie. So he's got me wrapped around his finger, paw, whatever. So every time Samson gets another treat, I'm going to create a new document and log that in the Azure Cosmos database. Maybe somebody's going to do some big data analysis on that someday and go, no wonder he was so fat or something. So the next one is another HTTP trigger function. This takes in data. So the first one really, I don't even need to, I'm not really even sending any data to it. It's just like, just do it, you know, hit it, new cookie, hit it, new cookie. This second one is a little different. It's a request query with some important information coming in, and I'm storing that information into the other collection. Now, I know, well, I'll tell you in a minute what we're going to do with that, but this is going to be interactive. So the third one is not an HTTP trigger, it's a Cosmos DB trigger, which means it's a trigger set up to listen to the database, right? I don't have to write a listener, it already knows how to do that. I just said, here's the connection string and here's my credentials. It's a trigger that listens to the database. When something happens, then it uses an input binding, and it goes and queries the other collection to get a list of the subscribers, and then it has an output binding that sends an SMS message to those subscribers, okay? So I'll let you go ahead, and if, you know, this demo has gotten a little harder to do since GDPR, I have to say, but so the exercise is, if you want to go to this website and give me your phone number, and I will delete the database at the end of the session, I promise. Don't put the plus sign in, but put your country code in. Then you can participate in this. And in the meantime, I'm going to flip over to the portal and show you what some of this looks like. Because I am a coder, not a PowerPoint girl. All right, so this is the portal. And I'm already in the functions, and I've filtered on functions, my function app for this session. And I've got 3 functions in here, right? One is the log Samson eating the cookie. That's the one that when I just say, he ate another cookie, he ate another cookie. The second one is notify subscribers, and the third one is subscribe. Now, when you create a function, and again, we wouldn't do this, this is a visual way of doing it. Because we're in the portal, right? This isn't the same experience you would have in Visual Studio Code. When you create it, though, I just wanted you to see, you have to predefine what trigger. Like, defining the trigger starts the whole thing. So once you've created it in the portal, you can't go and change it afterwards. But actually, if you were just looking at code, you could say, oh, I didn't want that to be an HTTP trigger. I wanted it to be a queue trigger or something like that. So you would just start, these are just templates, What's interesting to me about these templates is, again, it's kind of that list of the different kinds of triggers you have. I'm not going to go through and do all of these. So I'll open up this one. So again, I like this perspective because it's visual. So it shows me, what are the triggers, what are my inputs, and what are my outputs. So this just lets you, you can click on new input and get a template up for an input binding. This first one, log Samson eating the cookie, it's an HTTP trigger. It doesn't go and collect any other data in order to do this. And it has two output bindings. One is an HTTP response, and the other is outputting a document to Azure Cosmos DB. So when I first started learning how to do this, I set it all up. I just realized I keep pointing to my screen. Yeah, this is hard doing that too. Just if everybody wants to gather around. So I liked this way because it was really visual and it kind of handheld me through all the things I needed to do, right? So I said this is an output document, and so because I chose that, then there was a template that said, okay, what do you want the parameter name to be? And it has all these defaults. What's the collection name inside your Azure Cosmos database? What's the account connection? So the Lerman conference _ document DB, that's actually spelled out in my settings. Okay, so in the settings, it has the actual connection string. And a nice thing I have in there also is that God, I have this. I never used one before. Let me make sure I'm not pointing it into the audience. That would be terrible. Okay, so here, because this is checked, it just says if the collection doesn't exist yet, go ahead and create it on the fly for me. I've already got this created though. And then this is the name of the database. So I've got an Azure Cosmos DB account. I've got a database in there. You can have one or more databases in there, and a database can have one or more collections. And here's the collection. So I defined it all that way, and it was really nice to learn this way and go through all those things. But what it really does in the background is it's creating a JSON file that describes all the bindings. That's the real thing, right? So the template is just to help me through it, which is nice because first of all, I'm not a JavaScript developer, so me typing raw JSON sometimes it's not good because I miss one little thing and it takes me 4 hours to find there's a space in there or I missed a comma or something like that. But this is what it's really doing in the end is we've just got these different bindings. So here's the first binding, which is the trigger binding, right? The HTTP trigger. So that naming right there is not random, right? That is literally the name the API needs. We put it in there like that with the casing and everything, and it'll be able to find the API properly. So this is coming in, but it is a trigger binding, so that's really important. And I've just made the securities built in, and I made the authorization anonymous because it's a lot easier for demos than having to deal with passing in credentials, unless I'm doing a security talk. But as you saw before, security is not one of my areas of expertise. So you can see here's a second binding described. That's an output binding. That's the HTTP output binding that's going to send a request out at the end. And then the third binding is another output binding here. And this one is Cosmos DB. Again, not a random name. This is the expected name. The variable name of the output document that will be expected by my app is output document. I can call that foo, whatever I want, but I have to use that consistently in my code. And then here's the database name. Here's the collection name. Here's that Boolean for whether or not to create the database if it exists. So once I started doing it in the template and worked through it a few times and started seeing how things were going back and forth, then I started getting more comfortable with like, oh yeah, it's just a file. I can code this up. And again, this is with this function.json works when you're doing JavaScript programming in Azure Functions, but in C# we have attributes, and you'll see that in a little bit. So I have these different, all three of these different functions. They each have their different configurations, definitions of input bindings and output bindings. I'll show you the notify subscribers one. Then I'll show you the code, right? The stuff that I really care about. But still, I really care about the fact that all I have to do is give this little bit of information. This is an input binding. This is the connection string, right? Just little bits of information. I don't have to write all of that code for doing all of that. I'm just going to flip over to the, right, so here's one where the input binding here, the trigger binding, right? That's a Cosmos DB trigger. And then the rest of this information is about the same as you saw before. And this is an input binding. This is where I'm saying, okay, go out and go get some more data for me after you start up. So you can see here's a SQL query. So Cosmos DB has a SQL API, MongoDB API, and a couple of others. So SQL is what I've always done. So I'm just passing in this simple little query, right? And it's just going to go and get everybody from that list. And that's going to select all the phone numbers, right, that got put in there. And then here's another binding. This is my output binding for this particular function, right? And it's a Twilio SMS binding. And again, it's reading some information from my settings file. So let's take a look at the code. I'm just going to look at code for one of them because, it's code. Everybody knows code, right? So the real value here is look how little code there is to do all of this, right? Listening for a change in a database, going and querying another database, another collection in the same database, and then sending out a text message, right? That's a lot of stuff going on. But incoming documents, remember it's listening to the database. Documents is coming in whatever change happened in the Cosmos DB database, the documents that were affected, whether it was an update or an add, right? Subscriber list, again, documents of subscriber list, I defined those names of those variables in that JSON, in those configurations. So I have to be consistent throughout. And here, if I had a typo in here, if I'm doing it in actually coding and trying to debug in the portal, you're not gonna get a compile time error on that. You're gonna get a message when it fails at runtime. So yeah, this is what this is here for. So I'm just capturing the moment in time. I'm iterating through the subscriber list that I went out and queried, right? Again, that's just coming into here from the input binding. And then I'm building up a set of documents called messages, and these are formatted in the way that Twilio SMS expects them to be formatted. So I've got a body, and then there's a to. I'm putting the plus sign in here. That's why I said don't bother with your plus sign. Oh, I discovered something about the API today. If you have 25 really good phone numbers, but one of them's bad, because I'm not sending each message out one at a time, I'm taking a whole collection of messages and sending it to the Twilio API. If one of those phone numbers is bad, like there's a typo or something in it, none of them will go out. So I hope everybody who did it typed things in correctly. Because don't blame me, this thing works. I've tested it plenty of times. Anyway, so I'm building up the messages, and then I'm just saying, okay, I defined a binding, the output binding, I defined the binding, and I said that the variable name is called message, so that's what I'm saying here, and I'm just saying take that and set it to that. And then I'm saying it's done. And when it's done, that triggers it to just go ahead and finish up with the output binding, and we'll send the messages out. So the way it's triggered, again, is with a change to this one, the log Samson eating cookie, because that puts a document into the Samson eats collection. Right, and that's taking the request, it's reading the message, and honestly, all I'm doing is, I'm just doing a little test here, and I'm just saying, here's the message. right? It's reading the message and then creating the message. Doc to store, again, that's a variable name that I predefined, so I have to use that. That's what's in the configuration. And oh, no, I'm sorry. Output document is the one I predefined. Doc to store is the one I just created here. So I'm just saying, here's the document, just stick it in there. And that's it. Context done. We'll go ahead and push it into the database. So I can go ahead. This should be, this one should be running, but I just want to force it to run. It should be running and waiting and listening, but I'm just running it and making sure it's waiting and listening. Okay, then I'll go ahead and I'm going to click run here, and what this will do is actually run my little test that's going to create a record in there. And this is where I have to go like this. Yes? People are getting messages? Anybody? I didn't see mine popping up either. Oh, it takes a little longer when it's a whole bunch of them. Like when it's just me and I'm testing and I have one, it comes in really fast. Well, you want to read all my text messages? Hopefully, either somebody typed it in wrong, but we know it really does work. All those things are happening. So anybody? No? Yes, some other people are getting them. Okay. Not just the Twilio guy who, his probably come really fast because he's got a direct connection there. All right, so that was just, kind of getting an overview. And for anybody who's never seen these before, does it kind of make sense how that workflow and the different kinds of bindings? Like, I was really confused about the bindings when I was first listening to them. So, yes, no, you're tired, you had turkey for lunch, and you're all asleep, digesting. All right, so I'm going to, before I flip over to Visual Studio Code and show you a little more what it's like to really code these things, right, in the normal way, not on the portal. This is a really important addition to Azure Functions that came over the last year. And this was the thing I said, this extension, version 2 was just released. So this is called Durable Functions. And part of the Durable Functions API is the ability to take all these, each of the functions themselves is stateless, right? But it gives you the ability to have state. I have to get a little bit of water here. If you see me, I'm like, blah, blah, blah. Each one of those is stateless. So what Durable Functions does, it doesn't turn them into stateful functions that are running the whole time and running up your bill, right? I mean, that's the beauty of them, right? They just execute and do their thing, and then they're gone, and you're not paying for them while they're not executing. So, that's why they're stateless, because they keep going away. So Durable Functions, this extension, gives you the ability to actually have state when the functions are stateless. There's a number of different patterns, and I'm just showing you one way of orchestrating it, which is chaining functions. So we have a bunch of different functions. They all depend, like the first one might depend, the second one might depend on something from the first one, and the third one might depend on something from the second one, right? They're all still stateless, and they're all just running. There's your little charge, and then it stops. Then there's some state magically stored away somewhere, and then the next one fires up, and it knows how to tap into that state. And I thought this was really interesting because I'm like, okay, so how is this stuff persisted, right? It's being persisted somewhere, but I'm not, and I don't know if anybody knows I do a lot of work with Entity Framework and accessing data and interacting with data. So I was like, how is that happening magically? So what's interesting is that by default, Durable Functions is storing state into Azure Web Storage, right? You can actually configure that to store it in various other places, but by default, it stores it in Azure Web Storage. So in the case of F1 and F2 and F3, these different functions, because I'm using Durable Functions API, I don't have to write any of that code to make it persist. right? The durable function itself knows how to go and persist and read it. And then the other piece of durable functions, there's actually a number of features in there besides being able to orchestrate functions. The other one that was really interesting to me is durable entities. And it's not because it has the same name as entity framework. Everything's an entity. All our classes are entities. Unless they're a value object, but we won't go there. So durable entities are classes that are written in a way that they tap into the durable persistence mechanism of durable functions. So you can actually have a durable entity, instantiate it, and then it will kind of remember, again, without having been running the whole time in order to hold on to the state, right? You're using it, it goes away, that was the only charge you got, right? Maybe a day later you use it again, right, depending on how quickly it is, right? And it will be able to retain its state because the state is kind of magically stored in Azure Web Storage. So that's pretty cool. I wrote my very, very, very last article for MSDN Magazine. I don't know if any of you have ever read MSDN Magazine, but it was around for 30 years, and it had a column for the last almost 10 years, and the last issue was this month's issue. And my very last article was about durable entities. It was in preview when I wrote it, and by the time it got published, it had gone live. So what I'm gonna do when I show you in Visual Studio, I'll show you that demo. I'll show you that code for the durable functions and orchestration and the durable entities. And for those of you who do use Visual Studio or Visual Studio Code, I just want to point out that the extension, so Visual Studio Code has an actual extension that you have to use. I also, do I say it in here? No, okay. This isn't just about durable. This is just using the functions. I'm pretty sure it was in the slide where I was saying that you can use Visual Studio Code or the portal or the CLI. You do have to have .NET Core installed, and you do have to have the Azure Functions tools installed. So those are separate installs. And if you install the extension for Azure Functions, it'll say, hey, you got to install this thing. Here's a link, you know. And in the link, it's like, okay, here's how to install it for Mac OS. Here's how to install it for Linux. Here's how to install it for Windows. So the extension and Azure for VS Code and Visual Studio. Visual Studio, it's part of the Azure workload, right? So if you've got the Azure workload installed with Visual Studio, 2019, it'll be in there, and there's an explicit extension to install in 2017. So it gives you a variety of these templates, same kind of templates. It won't look like it did on the portal, but the same templates, right? You know, do you want to create an HTTP trigger? Do you want to create this kind of an input binding? Actually, there's not yet templates for input bindings, but that's okay. I'm so good at writing them now, it's okay. And also, you're in the IDE, so you get to debug and do all the things you can do in the IDE. But you can run it locally, right? You're just as though you're creating a website. You don't have to deploy it to a server in order to test it, right? You've got, there's a runtime, a local runtime, just like we have for like ASP.NET Core. Also, the extension gives you some cool capabilities to actually look at your functions as long as you're logged into Azure. If you've got VS Code logged into Azure, you can see your functions up on the portal and see if they're running or not. And I really like doing that because I leave them running and then the clock's ticking, not with my Azure functions, but actually, yeah, that's right, the clock's not ticking, is it? I guess I just get paranoid about using up my Azure. So you can see that you can actually stop and start them from there, which is kind of cool. And then I think one of the most important things is you can deploy it really easily. And the deployment, it actually zips up the entire function app, not just a function here, a function there. It's just like, we're just going to set a whole new version of this app, even if there's 5 functions in it. We're going to redeploy all of that. And then you could run it in the portal and look at it in portal, but you can't go and edit it in the portal, right? If you've designed it and deployed it from here, it's like a zip file deployment. Okay, just as an FYI, but I really don't edit and create in the portal anyway. But you can still look in the portal and see what's going on and do some logging and things like that if you need to. So that was, yeah, okay. So, oh, finally some coding. Oh, I'm not live coding, not when we have short sessions like this. So what I have here is, again, it's a durable function. Now I've got the Azure Functions extension installed, of course, and that goes into the toolbar. That's not the right word for this little section here, but the Azure, anything Azure, any of the Azure tools will be in here. So here's the Azure Functions, here's my Cosmos DB. Like I can actually see my Cosmos DB databases and see documents. If I refreshed this, I won't look at the actual documents. Let me just refresh it. I can see how many people actually, come on. There's still internet, right? Oh, good, see? Wow! What? I'm so impressed. Boy, when I've done this like in Germany, they're like, no way. We have rules. Okay, so that's as far as we're going to look at that. So I could actually look in here and see, like here's all of my functions on, like a lot of demos, right? Demo. Some are stopped. And you can, well, if it's stopped, oh God. Oh, okay. If I try to expand this, it'll either say, no, you can't see it because it's stopped or whatever. Let me see if I can see the one that we were working with. GOTO Functions. Okay. All right, okay, so there they are. Wonder how much I can see. Oh, that's interesting. Look. It's even showing me what the bindings are that are set up in there, right? That I output the things that are required for there. But I'm not writing against this. I just wanted you to see that. And also that we have some little icons up here, and these are really important. If you're starting with a new folder, new empty folder, and you want to create an Azure Function project, this will hand-hold you through in a similar way you got on the portal, but it'll hand-hold you through. I really don't want to do it here. Let me see if I can find another empty folder. Hey, test. Okay, so I'm going to do it in test, right? What language do you want to use? I'll say, oh, I'm not really doing anything, so I'll just say Java. I've never coded in Java. I don't have Maven installed. Okay, so much for that. But it asks you, what language do you want to use? What kind of a trigger are you using? And it'll show me, do you want HTTP? You want this, you want that? And then it asks a bunch of questions because it needs to know, I'm creating not just the function in that case, I'm creating the app. I'm creating a project which is the output of the project is a function app, and then there will be a function within that. So it asks some questions that it needs to know for settings, like the default settings. I can add more afterwards, but the basics, and then and it also has you say what kind of a function trigger do you want to start with. And it's not only just triggers. It's like, for example, to create a durable orchestration, you can say, oh, I want to create a durable orchestration kind of a project. So it'll give you some of the setup code. And it gives you also kind of a stake in the ground starting point class, so you can work with that. And that's how I first learned to do it. That person stopped early. I'm looking at the time here. It's okay, we got plenty of time. But they get to ask a lot of questions. Sorry. Like I said, it's so much I want to show you. So I have this. Let me just close this down so we can see a little more. So this is durable function. It's a little more complicated than just a straight function because there's a few other things I want to do here. So I have within this class, I have one function called say hello, and all that does is it builds up a string. It even has a little log, so it would be even less code. That is extraneous code there. All it does is it returns hello and whatever name came in, okay? And then I have another function, and notice that this function is specified as an activity trigger, right? So this other function in here, this is just the name I gave it, but this is an orchestration trigger, right? So this will know how to do orchestration. It will know how to persist and read to the, whichever storage mechanism I'm using for durable. And again, I'm just letting it do default, so that's going to be Azure Web Storage. There are local emulators you can use. I tried one that exists, just somebody in the community had created something that works on Mac, and there was just some things that weren't quite working with the durable storage. So because I'm on Mac, I'm actually just using web storage for this demo. There are 100% Windows-based emulators that you can use, but I'm not on Windows, so who cares? So this is my trigger, my orchestration, and what I'm doing is I'm calling that other function 3 times, right? And the first time I ran through this, I'm just going to go ahead and debug this. The first time I ran through this, I was like, wow, what's going on here? It was really interesting because you think the way we're reading it, it's going to do the first one, then do the second one, and do the third one. But each of these are, this here also is a type of an Azure function, right? A stateless function. So what's happening is, and this is stateless also. So I'm going to actually kick it here. So I'm going through, this is the first time I'm hitting it. Wait, oh, I didn't have the breakpoint in there. That's okay, we'll hit the second one. We'll just run it some more. I thought I just said step down. Okay, so here it comes again. So what it's doing is, it goes through and it says, oh, here's the first one. Oh, I haven't called this yet. So it calls that one that says, this one, yeah, I can't do it. This one, yeah, I can't do it yet. Right? So then it goes through again, and it says, oh, I already did this first one. Come on, this should just step through. Oh, it's not stepping through because I cleverly collapsed this, right? Because I'm building this all at once. So we're not seeing it step through. So can I put a breakpoint there? Yep, I tightened the code up before I did the demo. It looks much better though, doesn't it? But what it's doing is it's literally running my entire function, the whole orchestration function. It's running it over and over again, and it's going, oh, here's something. Oh, I haven't run it yet, right? This is the durable functions part that's doing it. I haven't run it yet, so I'll run that. And then like, oh, well, I can't do anything else. I'm just going to go through and go around. So it just keeps going through until it finds another function, runs the next function. Then it goes through again. Oh, I already ran those 2 functions, so, oh, here's another one. I'm going to run this, right? And then eventually it's like, oh, there's no more functions to run. Now I'm going to go down to now I'm going to finish it up. So what I did was I should have shown you, like the first time around, we only had 1, right? The second time I came around, then it added the second string. The third time I came around, it added the third string, right? And then when it's all said and done, so you saw it come down here, but here it was like, oh, wait, I can't run this function yet because I just ran the other one. I have to wait till I come around again and used up all the other ones, right? Finished through all the other ones. So this is here. This is orchestration right here. I'm orchestrating a number of different functions. But here I'm doing something else. I have an entity that I defined over here. This is a durable entity called counter. And it's just pretty simple. It's got add, reset, and get methods. And the most important thing, I've got it defined as an entity trigger here. So it knows it's a durable entity. Okay? And what happens is, I did this, I did this, I did this, and then I'm going to say, okay, I just ran through all of these, I ran through the whole orchestrator. Okay? So durable entities is keeping count of how many times I ran through the whole orchestrator, not how many times, how many different functions I called within it, just the whole thing. How many times have I done this process? How many times did I do this demo, right? And that's what the entity is keeping. Now, it's being stored, right? Here's a little bit of insight into how it's being stored in the web storage. I'm giving it, it's got an ID, right? So when it goes into web storage, and you can actually open up your web storage and look at it, and this one instance, right, I've got it persisted in there, and then every time I run this demo, it goes and finds that one in web storage and reads the number and then updates the number. So I found that, it went and read it. Now I'm just incrementing it using my add method. And then when all is said and done, I just want this to go away a little bit. When all is said and done, the output, right, the output of the durable function, and that's getting sent back as an HTTP request, because that's the kind of output binding I set up, is this string here, which has, well, I've already added those first 3 strings to the outputs collection, and now I'm adding a 4th thing, which is the orchestration has been run, whatever the current number of the entity, the counter entity is. So I'm going to run that. Now I have to browse to my local host. Please let me remember which host. 7. It was a 7 right there. Oh, yes. Oh, I just started it again. Oh, it was going to open it up for me anyway. So I've just gone, so here you can see it's coming through it, like the first call, the second call, the third call. So I've just gone through the full one again and again and again. I'm waiting for this to output. Okay. So this says I ran it 6 times. I just ran the whole kit and caboodle 2 different times. But I ran it 4 times when I was doing it before. So let me just refresh this here. So I'm going to call it from here. And I'm waiting for the debugger. So here, another beautiful thing here, very different than the portal, is that I can debug in Visual Studio, right? It just hit the breakpoint, and there it is again. And I should take all the breakpoints out, right? So we can just get back to here. Right, and I just ran through the whole thing the 7th time, right? So the counter is just I define the counter to just, in this particular case, the way I'm using that counter entity here is to keep track of how many times I ran through this demo. So durable entities, that was actually last time I did this talk in the same amount of time, durable entities didn't exist yet, so I really wanted to show them to you while I was doing this. So that is all I have to show you, and I think what's really important is to understand that I'm not saying you should stop everything else, forget about Docker, forget about all these other things, don't ever do another ASP.NET Core Web API, you should just do everything in serverless functions. And that is definitely not the message. It's another tool in your tool belt, right? So you can learn how that would fit into what you're working on and what solutions what problems it might solve, and where you might be able to take advantage of it. And again, these are just some of the points I'd made earlier. This is the one to show your boss, right? It's a little cheaper. We can get it out quickly, and you only get charged when you actually execute it. So I've already given this deck to go to so that you'll all, as attendees, have access to it. So don't worry about this if you can't write it all down. Of course, we all have phones to take pictures of. All right, well, thank you very much.